So this may seem like a strange place to start a video, looking at the top of a radio, but what I want to point out is, listen to that sound. That would be the fan. So I'm in AM and have about a 50 watt carrier, so if I turn the power down here, now we're down to about 20 watts, and if I talk into the microphone, you'll hear the fan comes on and it'll cycle back off eventually. Actually, let me switch to sideband. So now I'm in lower sideband, and you can hear as I talk, the fan will come on as the final transistor heats up in here, which we'll get to in a minute. Then eventually the radio cools down, but okay, there the fan just came back on again. It's going to stay running for a pretty good bit of time as I'm talking into the microphone, but as soon as I stop, you'll hear the fan shuts back off, and as I start talking, heats up again, fan comes back on, and it'll cycle on and off. If I go back to AM with a fairly good carrier, which is really going to drive the transistors hard, they're really going to get hot, you can hear the fans running there pretty continuously. So, then I unkeyed, fan's still running, not keying the mic anymore. You can hear it's fans running there. Actually getting some feedback there. Had the mic too close to the radio. But, so, what was wrong with this radio? Let's get her powered off here. Move the kickstand in. So what we have here is a Yaesu FT757GX. Customer sent this in with a few complaints. I'm not 100% sure about the one problem, and that one problem being output power dropping. Actually, let me just read the customer's note here. The issue with this one is, actually there's two problems I'm not so sure about. One is the piezo that doesn't quit once it's activated. Piezo meaning there's a little tiny beeper in here, so when you push buttons, it beeps. Actually, just turn the radio on. So you can hear it beeps. Okay, apparently that would get stuck on, and it just would not shut off. Eventually, just fiddling with some buttons, he might be able to get it to go off, or have to turn the radio off, turn it back on, and it would start working. Another problem, which I don't think actually has returned, no, it's not doing it anymore. So I'm not sure, it's just a bad connector in there. But he had mentioned over the phone that this radio did 50 megahertz, or 6 meters. And I didn't really say anything over the phone because, I deal with a lot of radios, and, I'm thinking to myself, FT757, didn't have the service manual in my hand, or the, even operations manual, and I'm thinking, no, that's not a 6 meter rig. I was kind of just, I was like, I'll see when I get the radio. And, and if you have a radio that's not designed to do 6 meters, something like this, covers up to 30 megahertz, but it's not going to cover 6 meters. And it was one of those, maybe somebody figured out how to cram 6 meters into it, but honestly, I don't see how. You've got the bandpass filter, you've got the filter board on the PA section, you've got tuned circuits all over this radio. It would be hard to put it, to be polite, it's just, man, almost damn near impossible to do something like add 6 meters to a radio like this without basically completely redesigning all the circuit boards, because they're designed to work from basically the very bottom end. If this had a Mars cap model on it, starts out at 500 kilohertz and goes to 30 megahertz. But getting above that, you're just not going to do it. Well, sure enough, when I first got the radio, turned it on, if you would hit the PMS button, the display would show 50-something megahertz, and turn the dial, and it changed. And I was like, holy shit, what the hell is this? And I played with it for a while, and I was like, yeah, but as I tuned down, I was up in the mid-50 megahertz range, but as I tuned down, I didn't really hear any noise whatsoever. This was hooked up to an antenna. But once I'd get down to about 51-something megahertz, I'd start to at least hear some static background hash. I was like, I wonder if this thing's actually receiving. So I hooked it up to a signal generator. No, it was not receiving in 50 megahertz. So, in the 6 meter band. So I hooked it up even to a sweep generator and swept through the entire frequency. It wasn't really receiving anything. When you hit the PMS button, it would just defy. I honestly don't know what the hell was going on there. It's not doing it anymore. Another problem he pointed out was that buzzer sound. Well, actually, that wasn't a problem he had said. He thought it had 6 meters. It didn't. It was a problem. The problem, he said, was the piezo buzzer. You'd push buttons, it would beep, but then the beep would just get stuck on and it would stay on. I have not experienced that here. I've got this thing fairly hot now. I've had this thing cooking. I've been putting it, running it through its paces, the torture test, especially with the fan, which is the other problem. So his complaint was the fan barely runs. Actually, let's see, how did he word it in the note here? The cooling fan seems to be working sporadically for only short bursts of air that really don't cool anything. Now, they do work in short duration. So when you first power the radio up, I don't even know if you can hear that in the camera. There's just one really quick. It literally like a split second, maybe 100 milliseconds or something. The fan gets power. It just cycles on really quick. I don't know if he meant it was doing that, or maybe he didn't have this thing hot enough for the fan to really come on. But when I first tried it, so I gave her a good torture test, put a good heavy carrier in it, stuck it in CW, hold a key down for a while, got her really hot. I would say yes, the fan was having problems. His other complaint was, the last complaint, the output drops as the radio warms up when transmitting. He's also got on there, also this radio needs a 50 watt AM carrier to reach 100 watts peak to peak during normal modulation, while my other 757 can reach 100 watts peak to peak with a 30 watt carrier. Please check it out thoroughly and give me a call when you have a rough idea. So I actually hooked this up after I've done a few repairs, actually one repair, well, two, which we'll get to. I'll take it's no screws in it right now, just have it put back together really quick. I ran a signal generator into this, key the microphone, even with a sweep. I've swept the signal from 300 hertz to 5 kilohertz through it, and or just put a continuous 1 kilohertz tone on in AM. It doesn't matter where you put the carrier power. You set the mic gain, run a signal into the mic jack, set the mic gain for 100% modulation, and no matter where I turn the drive power, I was at 100%. The output power would go up and down. Your peak power is going up and down, but it's going up and down as you. So, with the same exact drive level, it would maintain that 100% modulation basically from 0 watts up to, I think this thing will do like 60, or hell, close to 80 or 100 even. I have to look over there at the power meter. But, so, I know it has some problems, so I took it apart. Get the cover off of the PA unit, and actually, let me pause the video here, and I'll actually start it back up, and I'll show you what I actually did. Got the fan working. The power may have been dropping, I don't know, but let's get into it here, and I'll show you the one problem I did find, and the one thing that I did fix. And it has made the fan work. It's coming on a lot more, and staying on for a longer time. So just hold on a second here, let me get her popped apart. Okay, so if we take the cover, I'd already put a new piece of foam tape here, and taped the wires down. I'm not going to completely disassemble all that again. But what you have under here, you've got your driver and final transistors right here. You'll notice that there is a blob of heatsink grease on each one. Well, these are fine. The problem was over here. You'll notice there's wire comes in out one side. There's a diode in that blob. That's what that blob of heat transfer grease or heatsink compound is designed to do. Transfer some heat from the transistor into the bias diodes there. And there's the same thing over here on this one. This is actually the lead right here. That is the one that goes to the bias diode, comes out the other side, and down to the board over here. But there's also two other wires come in from the back side here that come in here. what those are attached to is a thermistor. So a thermistor is basically a resistor that changes value with temperature. And the problem from what I saw was you had the diode in here, they had the thermistor kind of sitting on top of it, but the leads are a little bit springy, and it had pulled up, and you could see crack lines in the heat transfer grease, or the heat sink compound. So it wasn't really making good contact and having heat transferred to it. Well, what that little guy does is it's a temperature sensor. So actually, if we look at the schematic, grab the service manual here. See, right there we go. So what we have is the fan connects right here. Just lay it down a little flatter. So we have the fan right here. This is the connection that goes to the fan motor. You can see there's a transistor and there's an IC here. But what controls this temperature-wise is that TH01. That's that thermistor. So basically what that little guy is doing is sensing the temperature of that one final transistor. And it uses that to basically tell the fan, hey, you need to cycle on before I burn the hell up. Well, if it's not making good contact with the final transistor, it has no sense of what the temperature actually is. So the fan won't come on very often, properly as it's supposed to be coming on. So what I did was I did not, for starters, use heatsink grease to put that put that little guy. Oh man, the lighting's horrible, isn't it? There, got a flashlight in here a little bit. Ah, damn it! I just need to pull this back off. See if I can get it off without ripping. Ah, there, that'll come off. Trying to avoid having to cut out a new piece of foam. It's the only problem they have. They run all these wires over top of these plates, and they tape them down. A bit of a pain in the butt to work on because of these things. There, now you can see what's going on in here. So, and hocus pocus focus. So actually you can see the schematic symbol right there. It's a circle, or kind of an oblong circle, with a resistor schematic symbol in the middle. And that's the two leads. But yeah, that's where that goes to. Now, I did not use heatsink compound on that. What I use is thermal adhesive. Now, I know some of you may be thinking, oh my God, you glued it down. How are you ever going to, if the diode or that thermistor or the transistor ever goes bad, how are you going to get it out? Well, the advantage of thermal adhesive is it's actually fairly, how should I put it, crumbly. Once it completely cures, you can actually go in there with, this ceramic screwdriver and go chunk and pry it out. You can scratch it off with your fingernails. It's actually fairly easy to remove. It's not like some adhesives that are just impossible to get off after the fact. This stuff actually, like I say, you can crumble it apart, but it does hold really well, and that's what I use it. That's why I use it in applications like this. I prefer it because over the years, over the decades of heating and cooling and heating and cooling and heating and cooling, well, you've got long wire leads here. That little thing could be can be pulling, and every time it heats up and cools down, it could be trying to move because it's got copper leads and stuff. It's going to move with thermal cycling. So yeah, the thermal adhesive will hold it down. The other thing I did was I made sure I actually had it down. I kind of left the diode off to this side and put that thermistor off to that side. So they're both actually touching the top of the transistor, instead of having the diode and then the thermistor sitting way up on top of the diode, because they had to heat transfer their heat sink compound up. Well, it's kind of hard to see with the screwdriver floating over top of it, but it was like that far off the top of the transistor, so it was really having a hard time picking up a good sense of the temperature. Other thing I did was, while I was in here, because a customer had mentioned it, while you're in it, because it's never been done before, if you could replace the memory battery, so that's been done. So instead of using that, what is it, like CR 1/3, I think is the battery type, it's a little short lithium-ion coin cell type battery. They're about that big around, and only about that long. And they mount down to the circuit board. Problem being, if you ever have to change them again, got to pull tape off, pull the covers out. They're a bit of a pain in the neck, and it's soldered to the circuit board. So I've shown this in a separate video some time ago in another radio that I did. Easiest thing to do there is go in with not a ceramic screwdriver, but a metal screwdriver, and just pry the tabs off of either side, but leave the tabs soldered onto the board. You're going to use those as terminals now. But what you want to do is basically take the battery out of the middle, solder a piece of wire to each one of those terminals, and then you're going to run them to something that can easily be changed in the future, and that's a coin cell. So you can get these little, what are these, 2032s, I think they are, CR2032 coin cells. Very popular size battery, and you can get these, again, designed for use in stuff like this. They actually have terminals already spot welded to them. And then I just solder, so I run a pair of wires down to the original terminals like this that are on this battery, solder the wires on there, put a piece of heat shrink tubing over each end, and then the same thing here, run the wires out. But now, in the future, 10, 15, 20 years from now, whenever this little battery needs to be changed again, the owner can do it. You don't have to worry about, oh God, I've got to pull the whole circuit board out. No, I don't like doing that. I like these. It's easier. It's a battery. It should be easy to get to. It shouldn't be a nightmare. It should be as simple as take a few screws out, fold your PA unit back, bam, there it is. You ever need to change it again, just cut the wires off. I leave a little bit of excess here, so there's plenty of wire there for a couple battery changes. But make sure you put some heat shrink tubing over the terminals so they can't short out. And then I put a larger piece of heat shrink tubing over the entire battery, so the battery itself the case can't short out against anything. And there's a nice little spot right here where you can just tuck that little guy down in there and safe and sound out of the way. Now, I did that and that. That's all I've done to this radio. Other than I did go through it and make sure that there weren't any loose connections, any of the connectors. So all of the coax cables, I pull them out and reseat them, and then all of the plugs, I give them a good jiggle and make sure, and push down on them to make sure they're all connected really well. Basically, put the radio, put the shield plates back on, pop the radio back together. Everything seems to be working just fine. That weird 50 megahertz thing I had when you push that one button, it doesn't do that anymore. That button's now actually functioning like it's supposed to. The fan is now cycling properly. One other thing actually I did while I was in here was I did lubricate the fan motor. Now there's not really a lot you can do it's not a really ultra, if you're familiar with like the old style fans like you'd have in some of the older Kenwoods or Icoms or Yaesus. If you think of like a Yaesu FT101 or something, big fan motors. Well, these just use little small DC motors. But if you take these two screws out and pull this fan up, you can actually take this fan blade off. There's a small set screw in there, a slotted set screw. You take that set screw out, this fan blade will easily come off. This fan motor does actually have, it's either a bronze or a oilite style bushing in the end of it, where the shaft comes through. Put a small dot of oil there, not a lot. Don't go saturating this thing. I see people over lubricate stuff all the time. All that's going to end up doing is getting onto the fan blade and then spraying out all over the case here. And then any dust that gets in this thing, that oil is going to act like a magnet. Just a dot. It's all it needs. It's a tiny little shaft, so it doesn't need much. Use a really high quality lubricant. But yeah, just put a dot of oil on there, because the fan was a little bit noisy before. It sounds fine now. There's no more harsh noise to it. It comes on, you hear the fan. Yeah, you actually hear the air, but yeah, it's really quieted the fan down. So that's pretty much it on this radio. Otherwise it seems to be working fine. Frequency's fine. Receive sensitivity seems fine. Like, honestly, I tell people, I have a lot of people ask me, I want a transceiver alignment done on my rig. Why? Well, it should be done. It's been a while. Honestly, people, this is a high-quality radio. This isn't a junk CB radio. A lot of people are familiar with most of the videos I do are on CBs, but I do work on ham radios. And I often tell people, a lot of times you won't see me doing videos because there's actually not a lot of stuff on stuff like these. Troubleshooting problems, yes. But as far as like alignments, honestly, people, a lot of times they don't need them. If the radio's working fine, you're probably not going to gain anything. It's a lot of work for starters. An alignment on something like this costs a hell of a lot more money than it does to do on something simple like a CB radio. You've got 3 layers of circuit boards. In the case of this radio, you've got alignment points here, you've got alignment points here, and then there's this many circuit boards on the underside here. If you flip this part over and take the bottom cover off, there's a bunch of circuit boards down there, just covered in alignment points. So it's a lot more work. It's going to cost you a lot more money. And it's, as I tell most people, it's a waste of money. These are good, high-quality radios. This wasn't a $99.95 special at CommiMart. Back when this radio was bought, it cost a lot of money. Nowadays, comparable radio, you're going to be spending 4 figures to get something like this or higher. They use better components. Now, is it going to need an alignment at some point in time? Yes. Any radio, no matter how well it's made, not even radios, test equipment, anything, it's going to need an alignment sooner or later. But in the case of radios like this, they're a better class of radio. Better components, better tolerances. It's going to stay in alignment a whole hell of a lot longer than those cheap junk CB radios that are made nowadays. So, unless you're having receiver sensitivity problems, low output power problems, or something like that, you've noticed, especially if you're an original owner to a radio, and you've just noticed over the last 20 years, it was fine for like 15 or 20 years, and you get to that point, and receiver sensitivity slowly starting to drop off. The guy down the street that you've been talking to for 20 years that used to hit you with an S9 plus, 40 dB, is now hitting you with like an S9 or an S8 instead of that plus 40 dB. Yes, you probably definitely need to have an alignment done. There may be problems. You may need to, because eventually this radio, just like any other electronic device, is going to need all of these electrolytic capacitors changed. Again, pain in the butt. There's a lot of them in this thing, a lot of circuit boards that have to be pulled. But until they start to fail, there's no need to change them. Now, fortunately, this is not one of the radios that has surface mount capacitors. If this was a radio that had surface mount capacitors of this vintage, I would definitely be suggesting replacing the electrolytic capacitors, because when they go bad, their most common failure mode is they leak. And they leak out onto the circuit board. And that oil eats the circuit traces off of the circuit board. This is a through-hole component board. So all the components are mounted up here on the top side. They go through-hole. Now, they're double-sided boards. But they're soldered on the bottom side. You really don't have a lot of problems with this style of capacitor compared to the surface mounts. They really just seem to be more prone to, their failure mode is leaking. These, they'll fail. Yes, some of the bigger ones might leak occasionally, but all of the other ones in this radio, usually when they fail, they'll just start to short out internally, and you'll end up with a problem. But it's not physical damage in the radio, where in the case of those surface mount style caps, they just seem to, their common failure mode, no matter how physically big they are, they just leak onto the circuit board. But radio like this, as long as I hook this thing up and sensitivity seems fine, there's absolutely no need to be wasting the customer's money to do an alignment on it. 10, 15 years from now, yes, it may need an alignment. But as of right now, there's no need for it. And honestly, I know so many people ask me, yeah, but you always preaching how you need to do alignments on CB radios. That's because they're cheap. They just don't stay in alignment. The parts aren't as good. The tolerances aren't as good. But there you go. There's a Yaesu FT757GX. Like I said, it looks like, I think the main problem was, as far as the fans going, was the thermistor, like I say, was not making good, it wasn't getting a good sense of temperature off of the final transistor. The output power, now his output power problem may have been if it was getting too hot because the fan wasn't cycling on and off properly. That's a possibility. Now, I never experienced that. I've had this thing cooking and had it on for an hour, just steadily. I actually had my little test jig here. and I'd just, transmit for like 5 minutes and then turn it off. I'd cycle it on for 5 minutes, off for a minute, on for 5 minutes. So it was transmitting continuously with, modulated signal. And the fan would come on, it was cool and fine, and the output power never changed. So, but like I said, I also made sure I reseated all the connectors. You gotta realize, there are a lot of connections inside of this radio. All these wires, these are all jumper cables that run from, a plug here back to either the PA unit or the IF unit, or all of these different filter boards. So, check. It never hurts. If you've got your radio apart, just give them a wiggle, make sure they're seated completely. Same thing with all these, just give them a quick wiggle, make sure they're seated properly. It could have been something, as some of the other problems this thing was having, could have been something as simple as that. Not, a slightly oxidized contact. So, there you go. There's just a few tips if you're working on one of these. The battery, like I say, that's a nice little, it just makes it easier to replace in the future. And you don't have to worry about this thing falling out of this slot down here, because once you put the cover back on this section and fold this over, all of this is right here. It can't come out. It's physically impossible for this battery to move anywhere. So that's a good little safe place to tuck it down in. But, like I say, dot of oil on your fan motor that's starting to get a little bit noisy. Now, you got to catch it, of course, before the bushing wears out. But, 1 dot of oil on that, you'll double the life of that bushing. And make sure you check that. The thermistor, make sure that's got good, the heatsink compound has neither dried out, or that the leads off of that thing just over the years, having from thermal cycling, started to spring that thermistor back up off of contacting the transistor, so it's no longer touching. And then it becomes more of an air sensor. It's an ambient air temperature sensor. You do not want an ambient air temperature sensor in here. You want a physical contact sensor touching that transistor. You want to get a good sense of the actual temperature of that transistor's body, not the air around it. So there's just a few little tips on this radio. So let me get her stuck back together, and I think this one should be ready to head back to the customer.